Hi guys, in this tutorial I'll show you how to move your character around on the screen, and by character I mean an animated sprite. And I'll also show you how to make a more advanced animation. Last time we looked at a normal animation where we took a sprite strip and animated that. This time we'll look at how we can take a sprite sheet and use that for animations. Because the sprite sheet will contain more animations, as you see on the picture I've put up here. It will contain more animations, and we need to tell our game when to use which frames for the animation. So when I press space, for example, it will attack in that direction I'm facing. I expect you to understand like the basics about animation, and if you don't, then I would like you, or you can look at this this simple animation tutorial I made if you think it's hard to catch up here. The project I'm using right now is the project I provided in the simple animation tutorial, so I'll be working with that and I'll adding stuff to that. So if you don't want to write all this code by yourself, you can go back to the simple animation tutorial on the link here and download that file, and then continue on from programming in that file. Anyway, we need to make some movement first, because before we can animate it in the right direction, I would like to be able to move my character around on the screen. If I play my game right now, I just have a character that is animated, and I can't move it or anything, and I can't change its animations right now. So what I want to do is that I want to be able to move to the left, right, up and down before I change the animation. So first thing we're going to do is that we're going to make a method that handles the input, and I'm going to make it private because I don't need to access it outside the player class, and it's private void, and I'm just going to handle input. With the class we use to handle our input in MonoGame is something called keyboard state, and if you write keyboard state, right click on it and press resolve, then you can include the XNA framework input namespace, and I'm just gonna call it key state. This function needs to react on what I'm pressing and which keys I'm pressing, and I'm gonna move on W, A, S, and D. So I'm gonna make 4 if sentences, that if statements that react on what I'm pressing. So if I make first one called key state dot is keyed down, and then you write keys to get the available keys dot, and then you can pick whatever key you want to press here on this list, and I'm just gonna do W first. And what this code has to do is that move character up, and we're not going to do any code right now. We need to add some different things first. I can just copy this and paste it 3 times. You can see I have 4 if statements now, and I can just change these to W, A, S, and D. All this code needs to be be run every time I press one of these keys. So this is up, this should be left, down, and right. Oh. Just like this. So right now we need to write some code in these if statements to make our character move to the right direction. And to do that we need a vector that decides this direction. So if we jump to our animated sprite class and go to our fields, then we can add a new vector 2 called sprite direction, and it's just equal to vector2.0. This direction is going to decide which direction our character is going to move in. So if we jump back to our player and say S direction, oh sorry, I of course need to make this protected so that I can access it from my player class. So now I've made it protected, so I'll be able to say S direction here, and I want to add the direction I'm moving in. And if you remember from when we're making games, our coordinate system is like turned upside down. So if I open my game and I want to go, if we say the mouse is the character and I want to go up, I have to say that's minus, right? So this is minus and this is plus down on the y-axis, and this is plus on the x-axis, and this is minus on the x-axis. So up is minus on the y-axis and down is plus on the y-axis. That's like opposite of what you learned in school. And yeah, the x-axis is exactly the same. So if I want to go up in my game, I need to add some direction to my current direction, and I'm gonna add a new vector 2 and 0 -1 because I want to go upwards on my coordinate system. This is basically the only thing we have to do in here for now. Then we have to go to the left, and if we want to go to the left, then we have to go minus on the x-axis. If we open this parenthesis, you can see that, okay, like this. You see the first parameter is the x-axis, and the next parameter is the y-axis. So we want to go to the left, so we have to go minus on the x-axis, and we don't have to do anything on the y-axis. And this is basically everything we have to do. Want to go down, then it's like +1 on the y-axis. If we want to go to the right, then it's +1 on the x-axis. So this is everything we have to do for now in the handle input. We need to call the handle input from somewhere, and to do that we can make a function called update. Right now we already have an update function in our animated sprite. If I click my animated sprite, see I have an update function here. And the animated sprite update basically just makes sure that we'll run through our animation from frame 1 to max. And this update function needs to be called as well. And it needs to check if we press any input keys. And that's why we don't only want to check our inputs, we also want to update our sprite at the same time. So what we're going to do here is that we're going to call base.update inside this one. And now it's going to say that we're missing an argument. That's why we also need to add game time here. Because as you can see in our animated sprite, it uses this parameter called game time. And we need to add it here. Oh, sorry. Wrong one. So now we successfully called our base update. One thing we need to do is also, like, if you can see here, this this function is called update and just public void update. We need to be able to override this because we want to call it from the player first. So when we call our update out in our game form here, if we do here, update here, when we call player.update, we want to call our player update first, and then we want to call our animated sprite update on the player. So we need to make this virtual void, this method, and this means when I make something virtual here in C#, that means that I'll be able to override it. So public override void update. So what I'm doing now is that I'm overriding the animated sprites update with this update. So I'll be checking for input first, and then I'm going to call the base update. So I am going to update my sprite afterwards. Yeah, and the reason I made it virtual is that to override something new to make it virtual. Yeah, so if we take our direction, s direction equals vector2.0, and I'm doing this to make sure that our character won't just run off in one direction because we already gave it some direction here, and we want to reset it every time we run our update so that it will check for the new input instead of running to the left all the time because I started pressing left. After that, I'll call my handle input, and it needs a keyboard state, and I can gain that by writing keyboard get state. Yeah, so now this class keyboard get state gets the state of my keyboard. So when I press A or something, it returns a keyboard state that tells my handle input function that I pressed A. Next thing I'm going to do is that I'm going to calculate delta time, and delta time is used to make our movement frame rate independent. So if I run it on a computer with a with better hardware, like very nice hardware, it will run as if it was running on a worse computer. I mean, if it will run on like my stationary computer here, it will run the same speed on my laptop, so it's frame rate independent, and I will move the same distance no matter how bad the computer is. So it's going to be a float, and it's called delta time, and it is equal to, have to cast it as a float, game time dot elapsed game time dot total seconds. Remember to pick total seconds. If you pick total milliseconds, then you're gonna have like totally different movement. And I want to be able to decide how fast my player is gonna move. So up here in my class, in the top here, I'm gonna make a variable called float, called my speed. It's just equal to 100, for example. So I'll be able to change the speed and change the movement of my player, and that means my s direction is multiplied equals my speed. So here I'm gonna add my speed as 100 to my direction. So now I know what direction I need to go through. I reset my direction, get the new direction from my handle input, which is up, down, left, or right. I calculate the delta time. I add my speed to my direction, and now when I've added my speed, I need to add this direction to my current position. Right now my current position is, for example, 0.0, and I need to change 0.0 to something like this direction. So I take S position, I think I have a position, I'm not sure. I don't have a position right now. Yeah, right now this position here I made is also private, and I want to be able to access this position from my player so I can change the position when I press my movement keys. So I'm just going to make this protected. And if I jump back in, I should be able to S position plus equals, because I want to add the current direction to the position without resetting the position. Like, I don't want to set the position equal to the direction. I want to add the direction to the position. That's S direction times delta time. And what it does when I multiply it by delta time is that it makes the movement frame rate independent. As I told you before, if I would have a worse computer, it would run the same speed as if I was running on a better computer. So it would take the same amount of time to run from one end of the screen, one side of the screen to the other. Okay. So now it should actually work. If I run this, I'm able to move my character from side to side and up and down. As you can see, if I press 2 keys, it's running to the sides. So what we want to do now is that we want to change this animation, because it's not much fun to have him running forward no matter what direction he's running. So we want to make some functionality that can change this direction according to what keys we're pressing. And if you look before, we had our sprite sheet, and on that sprite sheet there is some different squares, as you can see. I made this sprite sheet myself, so I know how many pixels there is between the different sprites and the different animations. So if we look at the top, you can see that our run to the front animation is start from Y position 0, and it's 50 times 50 each cell here. But if we go to our run right over here, we can see that it starts from Y position 100, and there is 1, 2, 3, 4, 5, 6, 7, 8 frames before it, so it starts on frame 9. And it's 0 index, so yeah, frame 8 I would say it starts on. So I need to tell my game somehow that, yeah, I need to run to the right, so I need to start on Y position 100, and I need to start from frame 8 when I run this animation, and it ends on this frame. So what I'm going to do is that I'm going to change the add animation method in animated sprite, and I want to change that add animation method so that it actually reacts on whatever I'm pressing, whatever key I'm pressing. So and we also want to make a play animation function so that we can play these animations. Oh, if I go back in animated sprite, you can see here we have our add animation, and we need to change the parameters here so that we can tell our animation that it starts on Y position something and X position this, and each frame is this big and everything. So first thing we need to do is that we still need the number of frames the animation is, but we need a new variable called Y position to tell where we need to start in the Y. We need to have something that tells which X frame it starts on, and this frame tells like where to start on the X-axis. So if it's the run right, then it needs to start on frame 8. And we want to be able to call these animations somehow. Like I want to be able to say play animation run left. So we need to add a name whenever we create a new animation, and we need to know how wide our frames are so that we can add the proper positions in our animation. So this is the width of each frame, and we also need the height. We also want to make an offset, because as you can see on the picture, some of the frames are bigger than others. For example, attack up is way bigger than run up, for example, and there's a lot more white space, and the character is not placed in the same position inside the frame as it is when I'm running up. So I want to be able to make an offset so I can align this character whenever I'm attacking up. So I'm gonna make one more parameter called offset, and that's a vector 2. And what I'm gonna do with that offset is that I'm gonna do something so that I'll be able to align my character properly. So the first thing we need to do is that we want to make this array of rectangles, as we do already. But it's a little different here, because we need an animation for each not animation, we need an array of rectangles for each animation we want to make. And to do that, we want to have a dictionary, because I want to be able to say play animation run left, and then it needs to find all the frames that is connected to play animation run left. So what I'm gonna do is that I'm gonna make a collection called a dictionary. I don't know if you're familiar with those dictionaries, but a dictionary is basically a collection that contains a key, and you can use that key to find whatever you're looking for inside the collection. So first thing I'm going to do is that I'm going to make this collection, and it's a private one, private dictionary, and it takes two things here. It's the value you wanna, like, it's the key you wanna save it as, and I wanna save my animations under a key as a string, so I can call it from a name like run left. So I'm gonna write string here, and I want to save it I want to save an array of rectangles. So I'm gonna write rectangle here, make this square to tell them that it's a dictionary that contains an array of rectangles, and these rectangles is saved under a key as a string. I'll call it as animations, just like this. So whenever I want to access something in the dictionary, I can call it with the string key, and I'll show you how it works. We jump back to our add animation. Then we need to change some things. We want to make a new rectangle array every time we add an animation. So here I'm gonna call this just rectangles, and I'm gonna write rectangle in front of it because it's just a new array every time we make one. This array has to be the same size as the amount of frames that we want in our animation. And this width, basically don't need that right now. Now that we've created this rectangle, like this array of rectangles, we need to use that instead of the original rectangles array we have here that only contains one animation. So basically we can delete this line here because we need to add it to this rectangle array instead. So I can copy this and paste it down here. This for loop is still valid, and because we only need to run as many frames as we have in our animation. So I'm gonna open this and write I in it because we want to add our frame to we want to make an array of rectangles that contains all frames to the current animation we're creating. I'm gonna make this and gonna create a new rectangle for it. And let's see, our rectangle needs a starting position, and our starting position is actually our I plus that start frame we want to start at. And up here we are giving a parameter called xStartFrame, and that's the frame we want to start at. So we're just going to write xStartFrame. So if we wanted to start at frame 8, then it would be first frame would be 0 plus 8, which is frame 8, and next frame would be 1 plus 8, which is frame 9. So that's how we can decide which frame we want to start at the X position. We also want the width to go here when we create our rectangle, so we are gonna multiply it by the width. Then we need the Y position, and the Y position we just give up here in our parameters. We don't need to calculate that somehow. And what else? We need the width here, and we give that up here as well. And then we need the height as far as I remember, yes. And now we have basically created our current animation. So if we write add animation run left, and I'm gonna pull this up again. If we say add animation run right, then we write it has 1, 2, 3, 4, 5, 6, 7, 8 frames, and in the Y position we would write, well, it starts in position 100 as it shows over here, and then we would say X start frame, that's frame 8 because it's 0 index, so 0, 1, 2, 3, 4, 5, 6, 7, 8, and we'll call it run right. The width, that's 50, and the height, that's also 50, and we are not adding any offset right now. So that's how we could create one animation. So far so good. So now we have our array of rectangles, and we need to add it to our dictionary of animations. So animations dot add. The string key we need to recognize this animation with is the name we're adding up here. So name and rectangles, because it needs an array of rectangles. And so we add to our dictionary, we add animation name, like an animation name run right, for example, and we add an array of rectangles which contains all the rectangles that is connected to the animation we're adding. Okay, so now we can create our animations. So now we should change some code here where we are playing our animation, because we're still using the old array to play our animations, and we don't want to do that. We want to be able to use our new dictionary to play the animation in our update. So as you can see here I'm I'm looking at the length of the array of rectangles, and what I want to do is that I want to look at animations, and I need to write animations dot length or count. I need to give like current animation width. So currently we don't have any variable that holds this current animation. We want to change. So I'm just gonna go to the top here and add. Just gonna add here. Now I'm gonna add it up here. Here. Private string current animation, and this string is gonna hold that animation I'm playing currently, so that I can look into my dictionary and see which animation I'm playing right now. So this current animation is going to decide which animation is going to be played. So here I'm going to use animation current animation dot length, -1, because it's 0 indexed. So right now it will run through our current animation animations index. What else do we need to do? We need to draw our animation. Right now we're still using our rectangle array, which shouldn't be used yet anymore. So in our draw function we also need to change rectangles to animations current animation. And we still have the frame index here. So if we open one more of these half squares, we can write frame index. So what it does right now is that in our draw function we access the animations dictionary, and in that dictionary we look for the current animation we are playing, and on that current animation we're playing we are finding the frame of the frame index. So the frame index we're currently showing is decided up here in our update as we did before. We're just accessing the current animation in the dictionary. So if we jump back into our player class, we can start adding some frames, and we want to do that from our player's constructor. So we are going to call add frames, because add animation, because that's what we called our function here. First it wants to know how many frames there's. So if we still use the rundown function, we can add 12, because there's 12 frames. It starts on Y position 0, it starts on frame 0, and I want to recognize it by the key down, and it is 50 times 50, and there's no offset, so new vector 2 0.0. So now I just added my animation down. I want to be able to play this animation somehow, and to do that I need some functionality in here that can change this current animation variable to that animation I'm playing right now. So I'm gonna make a new function here, and I'm just gonna call it play animation. And it's gonna take a string. And that string is just gonna be name of the animation I want to play. Yeah, this animation should only change whenever it's a new animation, so that if I press lift, it doesn't start over the old animation again and again and again. So if our current animation is different from the new animation we want to play, then our current animation is name, and our frame index is back to 0. The reason that we reset our frame index is that it's to make sure that we won't get any index out of bounds exception. For example, if we are playing our run animation that has 9 frames in it, and we switch our animation to idle or something, and there's only 1 frame in it, then we will get an index out of bounds, because it would try to access, it might try to access frame 9 from our run animation, frame 9 in our run animation when we switch, and then it tries to access frame 9 in our idle animation as well. So this frame index makes sure we don't get index out of bounds. So if I go back in my player and write play animation down, then I should be able to play the down animation. And as you can see, I'm running down now. Yep. If you want to see how it looks in a dictionary, just to explain how it works, we go to our add animation here. If we open our S animations, you can see that there is one, it's the 0 index here. And if we open that, we can see there's a key called down, because that's how we created our animation. And the value in that is an array of rectangles that contains all rectangles that is connected to the animation. As you can see, when I'm playing my animation, I have this dark square down here, and that's because I haven't. Yeah, okay, now I pressed the button. Don't mind that. Don't mind that exception. It's because I pressed the button. As you can see, I had that black square, and that's because I forgot to change my player sprite sheet from this sprite strip into the new sprite sheet. So I need to go here and press Add Existing Item, then go to my desktop and find player sheet, and then I can delete that other one, and I need to add the player sheet here in my load content. And then I need to select it as copy always. So far so good. So if I play my animation now, that square should be gone, and it is gone. We want to be able to change our animation, and to do that we need to add the following things. So right now I added all the animations from the sprite sheet. You can either just look at this and copy paste it, or look at the sprite sheet yourself to get the correct frames. First of all, I want to be able to change these animations according to what button I'm pressing. So I'm gonna go to my handle input method here. I'm gonna change my current animation by using play animation to whatever is gonna happen here. So first thing I'm gonna do is that I'm gonna add current play animation. This is just gonna be down. When I press down, and I can just copy paste this into all the spots here. Left. Oh, sorry, I mixed it up. Up, of course. W is up, and S is down, and D is right. Remember to write it with the right letters here. Like if you use a capital R here, you should also have used a capital R here when you added the animation. If you don't do that, then it won't be able to recognize it and find it in the collection. So right now, when I press my keys, it should be able to recognize which direction I want to go. So if I run this animation now, it animates to the right direction now whenever I run around here. But there's still one problem. When I stop running, it runs on the spot, and if I press 2 keys, it switches between the 2 animations. And we need to fix that somehow. Right now, when I press space, I can't attack either. So I want to add attack as well. So first thing we want to do is to add the attack. And we only want to move our character when we are not attacking. So up here in my player, I'm going to make a new boolean value called attacking, set to false. So I'm going to make an if statement around here. If attacking. If I'm attacking, well, we have to make like exclamation mark here, because it's only if I'm not attacking that I'll be able to move around. So if I'm not attacking, well, then I can move around and do whatever. Next one here, we're gonna check if we press the space key. So if key state, that is key down, keys space, well, then we want to attack. And we want to attack in the correct direction. And right now we can see that our current animation contains a direction here. So we can just look at that current animation and see what direction we are currently facing. So we need to go back into animate sprite to the current animation here and change this from private to protected, because we want to switch on this current animation. So if we're running to the left, well, then we're just gonna run attack to the left when we press the space button. So if current animation that contains, contains down, well, then we're gonna play animation attack down, and the same goes for the other directions. Up, attack, up. So if I run my code now, I should be able to attack to the different size. You can see there's offset problem still right now, and it just keeps attacking, but we're also gonna fix that. But at least it's attacking in the right directions right now. Okay, We also want to go back to idle, and to do that we'll make an else if statement here. So if I'm not attacking, we move to the sides. If we press else, if we're not attacking here, we want to idle to the right directions. So if current animation contains left, then play animation idle left. And we need to do the same for the other directions. Right, up, down. Idle down, idle up, idle right. So if I'm not attacking, I can move. If I'm attacking, then it looks at, if I'm pressing space, it looks at what direction I'm looking at. Else, if I'm not pressing anything and I'm not attacking, well, then I'm gonna idle to the direction I'm looking at. Right now it's just gonna break the attack. If you look here, it's just gonna keep idling all the time. So we need to do something about that. So we only switch to our idle position if we are not running in any directions. And we can do that by making an enumeration. That's how I like to do it. So I'm gonna make right here, I'm gonna write public enum, and it's called direction, my direction, and that can be left, right, up, down, none. I'm actually gonna put none first. Like this. If it complains about something, no. Okay, so now I have made a data type called my direction, and that direction is gonna I'm gonna make a variable of this enumeration. I'm gonna use that to decide which direction I'm running in. So in my, actually I would like to do that in my animated sprite. Sorry, I'm gonna cut this and gonna paste it in my animated sprite. Sorry if it's a bit messy, I'm just making this up as I go. So in my animated sprite I'm gonna paste this enumeration here, and I'm gonna make a new variable of this. My direction is gonna be protected. My direction, current direction, and its direction dot none as it starts. This would actually make the same. Sorry, if I do like this, would still be the same, but I'd just like to write it out so I can see what it actually is. So my direction, none. And in my player, I need to change this direction according to what I'm doing, so that I can use the direction to see whenever I'm idling on what side I have to idle to. So see, yeah. Here I'm gonna write a direction. What's it called? I can't remember what I called it. My direction. Sorry, current direction. And why can't I access it? Because it is protected. Okay, my IntelliSense is off. Give me a sec, I need to reopen it. Current direction equals my direction dot up. If I go up, dot left if I go left, dot down if I go down, dot right if I go right. And the same goes here. Down when I attack, left when I attack left, and right when I attack right, and up when I attack up. Yeah, and when I'm done with all this, I have to put it back into idle. So current direction, current direction equals my direction dot none to make it go back into idle. And one more thing I need to do, I need to change this variable called attacking. So whenever I press space, I'm attacking, and by attacking I mean that I won't be able to press any of these keys. So I need to set that variable called attacking to true here. I'm gonna copy paste that everywhere. Okay, so now I need to use this current direction as an animation direction whenever I change my direction. So I'm gonna jump back into animate sprite, and I'm gonna go to play animation. And in that if statement here, I'm gonna say that my current animation has to be different from the new animation I'm playing, and animation direction, current direction has to be equal to my direction dot none. And this, when I do this, it makes sure that I won't change my direction unless I'm in idle position. So when I press 2 keys, it won't change direction all the time. Let's see if I forgot something. As you can see, I can run around here. And if I press 2 keys, it just doesn't run vertically, it just runs to the side. And now when I attack, it still loops, because I never told it that I'm done attacking. So I need to make some functionality so that whenever I end an animation, it tells me what animation that ended. And I need to tell it that I'm done attacking, because when I'm attacking, I can't press any keys. And I can't press any keys because of this if statement here that says I can only move as long as I'm not attacking. And when I press attack, it says this to true, so I'll never get back in here. I can do a quick fix for that. If I make a public abstract void and call it animation done, and takes a string called animation, and I want to call this animation done whenever I finish an animation. And every time I finish an animation, I know it ends up here where I reset my frame index. So I'll say animation done, current animation. So when an animation finishes, it will call this animation done, and it will set the current string as the current animation here. So if I go back into my player and build here, it should give me an error saying my player class doesn't implement all inherited abstract members. And that's because I created my abstract animation here. So if I right click on animate sprite and press implement abstract class, it will implement the animation done function down here. Sorry if I zoomed out. Hope you could read it. That means that every time an animation finishes, this animation string here is equal to the current animation that finished. So if animation that contains attack, well, then attacking is false. So if I put a breakpoint here, oops, I need one more, and I attack to one of the sides, then the current animation that finished is attack right, because in my animation here, my current animation here, I wrote that it should take the parameter current animation and call the function animation done, which is this one, and it calls it like this, attack right. So if my current animation contains attack, it will set attacking to false. So right now I'm able to run around and attack, as you can see, in the correct directions. And whenever the attack finishes, it jumps back to the animation it was before. And if I hold down a key and run, it stops running when I'm attacking. As you can see, there's a problem here, because it has some flaws here with the offset. So what we need to do is that we need to apply the offset to these animations. And I have written them down somewhere. Give me a second, I need to find them. Yes. And the offset for attack right is plus 15 minus 5. Offset for attack left is minus 5 minus 30, as for me at least, and minus 13 minus 27. If you run the code now, nothing happened. There's nothing different right now, because we're never using the offsets. So we need to go back to add animation, and we need to use this offset we are setting here. And we do that by making another, what is it called? Another dictionary. And the dictionary we're going to be using is almost as the same as this. It's just going to be called offsets, and it doesn't contain an array of rectangles, it just contains vector 2. Yeah. So now when we have this dictionary, we need to add the offset to that dictionary. And we just do that in our add animation here. We just say soffsets.add name dot offset. So now when we have added all our offsets, we can use this offset in our draw function so that it fits our animation. For example, if I jump down here, right now you can see that we have our texture, we're drawing it at a position, and it's this position that we need to change. And we do that by saying sPosition plus sOffsets, and we're just going to give it the current animation so it knows how knows where to place the current animation according to the offset. So if I run around now and attack, you can see that there's no problems with the offset. I'm sorry, I'm lagging a little because I'm recording and my laptop sucks. As you can see, there is no problems with the animation now. Yeah, and that's basically it. If you have any questions, post them in the comments and I'll get back to you as soon as I can. I'm sorry if it was a little messy at some times, but I did this right off the bat without thinking about how to do it. So yeah, we'll see how how it turns out and how easy it is to learn anything from it. I really hope you could use it for something. Okay, that's it.